All right, here we have a graph with 2 lines and a quarter circle. And it tells us that, and it also tells us that the point 3, 3 minus root 5 is on the graph. First thing it wants us to do is find the value of the integral from -6 to -2, given the integral from -6 to 5 is 7. So the integral from -6 to 5 of f of x ought to equal the integral from -6 to -2 of f of x plus the integral from -2 to 5 of f of x. Would you all agree with that? That's just sort of how integrals work, right? The integral from a to c is a to b plus b to c. Yeah, okay. So the integral from -6 to 5 of f is 7. We're looking for this integral. And we're adding to it the integral from -2 to 5. Well, what's the integral from -2 to 5? It's just the area underneath the curve, right? So from, let's see here, -2 to -1, that ought to be 1/2. I'm not going to write it all the way out because this little triangle here cancels out with that one, doesn't it? They do, yeah. So this one in blue will cancel. Oh, that's not good. But this one in blue, everybody agree with that? And then this little piece in red will cancel with this little piece in red. So I'm just going to ignore all of that, and I'm just going to find this trapezoid that I'm going to do here in group. Nope, that's not green. Click on green. There we go. Just so that's not a straight line. There we go. This trapezoid here in green. Thank you, Noah. I can't wait for you to teach 6th through 9th graders things with your ability to speak coherently. All right. And this area we also need to find. So the green piece is the trapezoid. Base 1 is 1. Base 2 is 3. Divided by 2. Find the average of the bases, multiply by the height of 1. And what do you get for that? Well, we'll do that in a second. And then the black piece right here underneath this quarter circle ought to be the full square minus the actual quarter circle. So the full square is 9. And then the quarter circle is 1/4 pi times the radius of 3 squared. So we've got, what does this become? This is 2 plus 9. That should be an 11 minus 9 pi over 4. 7 equals, I'm just going to call it A. This is going to be equal to A, so I don't have to write it again. Just to make myself, just to make my life easier. All right, so that A, that value of that integral should be what? 9 pi over 4 minus 4. Yeah, that's our integral from -6 to -2. And they gave you 3 whole points for doing that correctly. They gave you 1 point for the right setup here. They gave you 1 point for correctly finding the value of the integral from -2 to 5 as 11 minus 9 pi over 4. And then they gave you 1 point for solving for that other integral. Good? Anybody have any questions on that?
Zoom good.
Zoom good. Wonderful. His name is Walter, but yeah. Walter / Justin. Same thing. It's almost the same. Got the same number of letters. Yeah, I just said that. All right. What about this one? Part B. What? Yeah, what do we do?
Well, you know that
All right, so the first thing that we should do is we should integrate, which should give us 2f of x plus 4x. And then we should evaluate that from 3 to 5. Everybody good there? Okay, so that's what you were going to say? Gotcha. So then we just plug in our 3 and our 5 and we subtract. So we have 2f of 5. F of 5 is 0 plus 20 minus the 2f of 3. So that's minus 2 times 3 minus root 5. And then minus a 12. So we got 8 minus a 6. That'll be 2. And then plus root 5. Oh, sorry, plus 2 root 5. Good? That was worth 2 points. 1 point for correctly integrating, 1 point for correctly getting 2 plus 2 root 5. Any questions or issues on part B? All right. Part C. The function g is the integral from -2 to x of f of t. Find the absolute max on the interval -2 to 5. So an absolute max on a closed interval can occur at endpoints. Always check the endpoints. So -2 and 5. These are two values. And also any places where the derivative goes from positive to negative. And what's the derivative of g? Just f of x, right? So anytime f of x goes from positive to negative is a possible absolute max. So here's one place where that happens. Are there any other places where it goes from positive to negative? Goes from positive to negative? No. Goes from negative to positive. That's a critical value, but that one's a local minimum, so we don't need to worry about it. So we have -2, we have -1, and we have 5 as the three values that we need to really check here. So the value at -2 is what? Not only probably just 0, it is definitely just 0, right? The integral from -2 to -2 of a function is 0. All right. What about g of -1? Well, that's the integral from -2 to -1. What is that? 1/2 of base times height. Just a half. Right. And then let's see here. We can clearly see that we're subtracting a little bit off and we're going to add way more in over here. Right. What is g of 5? That's the integral from -2 to 5, which is, well, we already did that earlier, right? The integral from -2 to 5 with 11 minus 9 pi over 4. So our absolute max is 11 minus 9 pi over 4. The absolute max is not 5. It occurs at 5. The absolute max is 11 minus 9 pi over 4. Make sure that this is what you say your answer is, not 5. And that was worth 3 points. 1 point for noting this, 1 point for checking it at -1, and 1 point for getting the value of 5 as your absolute max. Everybody good there? Any questions? Any complaints? Any concerns?
Did you have to list out all the other values for the possible absolute maximum using those other points for x, or could you just find the answer?
You needed to show that at the 3 places where it could be at a max, these are the 3 places it could be at a max. You needed to show that this one was the largest for those 3. So yeah, you needed to show those other 2 values.
Okay, thank you.
What do you mean? You explained it, but you didn't check the values. Sorry, everybody in the Zoom. I was trying to listen to Noah's long-winded explanation as to why he did not write out all the values. Did you get the actual value of 11 minus 9 pi over 4 though? No, because you didn't read the question. Yes, one of my tips for the exam is answer the question. Yes, it's actually written on the tip sheet. Yeah, everything you said is fine. I mean, they would probably give you the points for that up until the last point because you didn't actually answer the question. Okay. Anybody else have any questions on that? All right, part D. It's like we need some more room for this one. Well, the load is exponential is 1 of 10 to the x minus what? Is it f prime of x? 3f prime of x? Over something with an f of x, right? And some. Nice, interchange it. All right. All right, so let's just plug in our values here, because that's what we should do with the limit. Usually these come out to be indeterminate when they put these in the free response. Well, not maybe usually, but often. But we still got to plug it in and make sure, because if it doesn't come out to be indeterminate, then you get an answer, right? We have 10 minus 3 times f prime of 1. Well, we got to go back and figure out what's f prime of 1. F prime is the slope of f at 1, and that is, looks like it goes up 4 over 2. It's got a slope of 2. Oh, looks like it's not going to be indeterminate, that's for sure. Then f of 1, what's f of 1? 1. Okay. And then the inverse tangent of 1 is pi over 4. So we got 4 over 1 minus pi over 4. And they gave you 1 point for that. Easy enough? How do we feel about the graph FRQ question there? I said that the quiz tomorrow is just on motion problems. Is that what I said? Yeah. Yeah. Next week it'll be on graphs and I don't know, something else, probably differential equations or something. Okay. So this week just on the motion problems. Everybody's good with the motion problems. We don't need to do any more motion problems. Yeah. So we can continue with the graph problems. Let's do some more graph problems.
Wait, could you go?
Oh,
Could you go to the first slide?
Yeah, you can go to the first slide.
Wait, so how come you did not test how come you only tested -1 for part C, and how come you didn't test like x equals a half?
I didn't test x equals a half because and they showed x equals a half in their scoring guidelines and the value there, but you don't need to because the derivative, which is f, is going from negative to positive. So if the derivative is going from negative to positive, the function is going from decreasing to increasing, and therefore that's a local minimum. So a local minimum is not going to be an absolute max.
Okay, I see. Thank you.
Yeah, and in their scoring guidelines, like I said, they made like a chart, and then they wrote in the values at -2, -1, 1/2, and 5. But the points were only associated with identifying that x equals -1 with a possibility. So sometimes they don't write in the values where it's a min or where they want a max. Sometimes they do. Good. Great. All right. Let's do this one then. 15 minutes ought to be plenty. We'll give you 15 minutes. Have fun. Ready? Go. I forgot to start recording. So we have G as f prime, and then f of -5 is the position at 1 plus the integral from 1 to -5 of G. So better would probably be to write this as 3 minus the integral from -5 to 1 of G, just because that makes our integral finding a little bit more straightforward. So the integral from -5 to 1. Well, from -5 to -1, we should better find that value. So we've got 3 minus. -5 to -2 is 9, right? And it's below the x-axis, so negative. And then we've got another negative down here, 1/2 base times height. Base is 1, height is 3, so minus 1/2 of 3. Then from -1 to 0, it's just 0. So you can ignore that. And then we're going to add this piece between 0 and 1. So that should be 1/2 base times height. And whatever that, whatever that comes out to be, which is just 1, that's 1, right? So we got what? -9 plus 1 is -8 minus 3 halves ought to be, what is that? -9.5. 3 minus -9.5. 12.5. 25 halves. Everybody good with that? Looks like that was worth, there it is, yeah. 2 points. 1 point for finding the value of this integral. There's 1 point for integral, 1 point for answer. So I'm not sure if it's finding the integral or if it's the value of that integral. I think it's just having that integral. Any questions on part A? That's good. Zoom, you're good?
Zoom good.
Wonderful. All right, part B asks us to evaluate the integral from 1 to 6. Okay, so the integral from 1 to 6 of g. Well, the first part of that is a square with an area of 4. And then the second part of it is the integral from 3 to 6 of the function they gave us. Right? What was it, 2 times x minus 4 squared? Yeah. And so we'll just integrate that function. This is a u sub, right? U equals x minus 4, but du is just dx. So really, you can just use the power rule on this one. 4 plus 2 times x minus 4 to the third over 3. We'll evaluate those from 3, 6. We got 4 plus 6 minus 4 is 2. 2 cubed is 8, 16 thirds. And then minus 3 minus 4 is -1. -1 cubed is -1. So this is minus a -2 thirds, so really plus 2 thirds. And 18 thirds is 6, plus the 4, that'll be 10. Good or no? Wow, they gave you 3 points for that one. 1 if you recognize that it needed to be split into the 2 different pieces. 1 for correctly getting the antiderivative of the piece from 3 to 6, and 1 for the final answer. Any questions on part B? All right, part C. Part C says, when is f increasing and concave up? And when is f increasing and concave up? So f to be increasing means that f prime needs to be positive, and to be concave up means that f double prime needs to be positive. Okay? If f prime is positive, that means that g is positive, and if f double prime is positive, that means that g prime is positive. So we can go back and look at our graph. When is g positive? Well, g is positive from 0 to 6, effectively. I mean, it's 0 here at 4, but when we talk about increasing intervals, which is what we're doing with that, they would say that that's still the same thing. So this is from 0 to 6. And then when is the slope of g positive? G prime. Well, that'd be from -2 to -1, but that's not an overlap, so we can ignore that. Right? We don't care about that. From 0 to 1, the slope is positive, and from 4 to 6. Okay, so we would say 0 to 1, 4 to 6. We might add in there also, what did I say, -2 to -1? That's how it was. But that one doesn't overlap. These do overlap, though, 0 to 1 and 4 to 6. So we would say this is true on 0 to 1 and 4 to 6. Because we're talking about concavity also, we're going to have open intervals. Any questions there on part C? All right. Part D. Find the x-coordinate of each point of inflection of the graph of f. So point of inflection for f means that f double prime changes signs, or g prime changes signs. So we're just looking for any time that the slope of g goes from positive to negative. So what? Or negative to positive. Yeah. Positive, negative, or negative to positive. So here the slope of g is from -5 to -2. 0. Then it becomes positive. Is that a change from positive to negative or negative to positive? No. 0 to a positive is not a point of inflection. Positive to 0, point of inflection? No. 0 to positive, point of inflection? No. Positive to 0, point of inflection? No. 0 to negative, point of inflection? No. Negative slopes to positive slopes, point of inflection? Yes. Only at x equals 4. Let's say f double prime goes from negative to positive. Good or no? Is that what it said to do? Find the x coordinate of each point of inflection on the graph of f. No, you made the same mistake. You didn't answer the question. Same mistake. Just in the opposite direction. Okay, fine. All right, everybody good with that? Oh, for C and D, so D was 2 points, answer with reason. C was 2 points, interval with reason. We got our reasoning up there. You want to write a sentence out. Any questions there on that? Everybody good with that question? Now, yesterday I would have ended class right now because I would have been very confused about the time, but we have plenty of time to do one more. Let's do one more graph FRQ. Probably, although there's not one every year, so. "15 minutes, ready, go." So for part A, we want to find f of -6 and f of 5. We know that f of -2 is 7. So we'll say that f of oh, forgot to stop the timer. All right, f of -6 ought to be the initial condition, which was 7, plus the integral from -2 to -6 of f prime. So we would have written that as 7 minus the integral from -6 to -2 of f prime, and then we would have found that integral. So we have 7 minus from -6 to -2, that's just 1/2 of the base, which was 4, and the height, which was 2. So what does that come out to be? 7 minus 4, 3. And then for f of 5, you would have done 7 plus the integral from -2 to 5. And the integral from -2 to 5 starts off with this piece that's below the x-axis. So we're going to have a negative of this. And then it's the semicircle. Right? Semicircle is 1/2 pi times the radius squared. Radius is 2, so that's 1/2 of pi times 4. And then we've got a piece above, so plus base is 3, height is 2, so 1/2 3 times 2. So we end up with 7 plus 3, so we got 11. That's 7 plus 3 is 10, right? Yeah, I don't know why. I said it. Why did I say? I said 11, but I wrote a 0. My brain works better than my mouth, apparently. No, but for literally 5 seconds. Yeah, I don't know. I don't know what in my head was. I'm not sure what was going on in my brain that I thought of the number 11, but then still wrote a 0. They're pretty close. Anyway, 10 minus 2 pi. 10 minus 2 pi. There's a good value. Everybody good with that? That was worth 3 points. 1 for each of the values, and 1 for using the initial condition. So I don't know how you would have got either of the values without using the initial condition, but yeah. All right, when is f increasing? F is increasing when f prime is positive. I mean, you know, they like to make it greater than or equal to 0 because they like to use the closed brackets. So it's positive from -6 to -2, and then again from 2 to, what is that, 5? And 2 points, answer with justification. They'd like you to write it. I mean, you know, they wrote f prime of x is greater than 0. Yeah, I mean, that's literally all they wrote. They wrote f prime of x is greater than 0 on these intervals. Yeah, so I mean, okay, they wrote greater than. This is the point that I have the issue with them with, right? I mean, I would normally say f prime is greater than 0, and I would make those open intervals if this was not for the College Board. In their scoring guidelines, they write f prime of x is greater than 0. Oh, they actually, yeah, okay. It says they wrote f prime of x is greater than 0 on -6 closed bracket to -2 open parenthesis, and open parenthesis 2 to open parenthesis 5. And then they said, therefore, f is increasing on the intervals, and then they put all of it in brackets. So, you know, this is the issue that I have with it. I don't know what to tell you other than put the final answer in brackets. And I have done that in the past, not this specifically, but just in general. Yeah, back then. Is that for your brother? Yeah. Yeah, that was fun times. All right, part C, find the absolute minimum of f on the interval -6 to 5. Well, minimum can occur at an input, so at -6 or at 5. And it could occur anywhere where a derivative, f prime, goes from negative to positive. So just one place for that too. So really we just need to look at f of -6. F of -6 is just going to be what? Where you found that? What was it, 3? We need to find f of 2. What's f of 2? That's 7 plus the integral from -2 to 2 of f prime. And from -2 to 2 of f prime, that was this -2 pi. So that's 7 minus 2 pi. And then we already found f of 5 to be 10 minus 2 pi. So looks like the absolute minimum of those ought to be 7 minus 2 pi. Because that's smaller than 10 minus 2 pi and smaller than 3. So you have to show. Well, you already had f of 5, but yeah, you need to show them. Yeah. 2 points for that, 1 for considering x equals 2, and then 1 for the final answer. Well, yeah, so I mean, they show it in a chart, but I don't know. It's hard to say. Their scoring guidelines aren't necessarily perfect all the time. So. All right, then the last one real quick. This was 2 points for f double prime of -5 and f double prime of 3. Find the value or explain why it doesn't exist. F double prime of -5 is just the slope of f prime. So that appears to be what, -1/2. And f double prime of 3, we would say does not exist. You could say that it's a corner, or you might want to state like the slope from the left is not the same as the slope from the right, or something like that. Perfect. That works. Yep. Any questions on that? If you have any questions on that, you're welcome to stick around and ask. Otherwise, you are good. Have a wonderful day. See you tomorrow for the quiz on particle motion.